Let's get started with the supervised learning algorithms. These algorithms use two main functions called as classification and regression. So, what is classification and what is regression? Both ideally do similar things, but the output is in somewhat of a different fashion. So, classification with prior knowledge and training, predicting as to which category an input belongs to. For example, let's say that you have different color pictures and you want to categorize them into different baskets. So, a red picture would go into red, a blue into a blue, and yellow into a yellow. So the input is ideally put into a category in the output. So it has to be in a category, either red, blue, or yellow, spam, not spam, and so on. Regression would categorize the input into a continuous value as an output. For example, given the zip code, you can predict the price of the house. This can be, for example, $405,000. This is not a basket, it is a specific price point. So that's the large differentiation between classification and regression. And of course, regression can be molded into classification. All right, now let's zoom in to the different types of algorithms we have. Now, we have chosen a few important ones. This is by no means an exhaustive list. This is to get you started. The first one is linear regression. So, as the name goes, it's a regression method, and this would predict the change in the output variable based on the change in the input variable. For example, how does my sales increase with an increase in Google Ads? So, the relationship is linear, and this would be regression. Next is logistic regression. Now, this is very much like the linear regression, only that the output is either a 0 or 1. You can also imagine as yes or no. For example, if given a set of characteristics, the algorithm would say that the lesion is benign or malignant. So it cannot be in between, it cannot be a number, it has to be part of yes or no, benign or malignant. The next example is a decision tree. This algorithm divides the data or information into as many decision tree or branches as possible, finally arriving at a result. For example, let's say that you want to understand the attributes of people who buy an iPhone. So you would have decision number one is, do they give design importance? If it is yes, then you would say, do they give security importance? If it is yes, then you would say they don't have a specific price point in mind. And if it is yes, then you would say that yes, this customer would buy an iPhone or is more likely to buy an iPhone. The next is a popular method called naive Bayes. This algorithm has the knowledge of certain independent parameters which might affect the outcome, and on top of it, it builds a probability to come to an outcome. For example, this could be a tweet, and you could run a sentiment analysis on the tweet. So you would say that if there is a word called bad, then of course this is a negative tweet or a negative review, and so on. So the word bad relates to negative review. So that is information which the algorithm has. This relationship is non-linear and it is classification. Some other examples are random forest algorithm. This is also a decision tree algorithm, but it has some extra layers added to it. So this one makes multiple decision trees and takes the best out of them to predict the output. For example, applications are predicting power usage patterns, predicting call volume patterns, and so on. In a similar bucket are AdaBoost, another variation of decision trees, and then gradient boosting trees, another variation of decision trees. So there are many algorithms which can be used to solve your specific problem. Great. In the next video, we'll take a look at the unsupervised learning algorithms.